Hey guys, this is Shashank and now I'm going to solve the fourth question in the maths and some paper. Okay, so the fourth question states solve the given non-homogeneous linear ODE by variation of parameters or undetermined quotients. Y double dash plus 9y equals cosecant of x. So I'm going to be using method variation of parameters. It was given by Lagrange. So general equation in this sort of method is considered y double dash plus y dash times px plus y times qx equals r of x, and the solution is y. Has two components, that is the homogeneous solution, the particular solution. Homogeneous solution is the solution of the equation without cosecant of x, that is without r of x, if you will. So since this uh, equation lacks y dash, we can equate this to 0. So it doesn't have any p of x, it only has a q of x and an r of x. Here q of x is 9 and r of x is cosecant of x. So let's start solving for yh. So y double dash plus 9y equals 0, and we are going to find the auxiliary equation. So the auxiliary equation will be lambda squared plus 9 equals 0. Obviously, it's very simple, and that is going to be lambda minus 3i squared equals 0. So lambda will equal plus or minus 3i. Now this is lambda is supposed to be in the form a plus ib. So here a equals 0 and b equals 3. A plus or minus ib. So yeah, we have a equals 0 and b equals 3 only for y of h, and now yh equals homogeneous equals c1 y1 plus c2 y2, and y1 is equal to e power minus ax times cos bx, y2 is equal to e power minus ax times sin bx. So since a is 0, these two become 0, become 1, because since a is 0, you get e power 0 as 1, and cos bx and sin bx, so you get cos 3x and sin 3x, and I'm going to find out y derivative of both these things, because they'll be we'll be using them in finding the Wronskian. Sin 3x, 3 cos 3x. So we have yh homogeneous equals c1 cos 3t plus c2 sin 3t. Unfortunately, we can't find out the values of c1 and c2 here, because we don't have we are not given any initial values, so we can't solve for c1 and c2. So okay, let's start solving for yp. Now yp has a direct formula in the method of variation of parameters. Minus y1 integral y2 r of x dx by w, that is Wronskian, plus y2 integral y1 r of x dx by w, that is again the Wronskian. So now we have Wronskian equals y1 y2 dash y2 dash, the determinant of these, and that's why we found them out beforehand. We have cos 3x sin 3x minus 3 sin 3x 3 cos 3x so this is going to be this times this minus this times this, so 3 cos square 3x plus 3 sin square 3x, that is 3. So now we have yp equals minus cos 3. Since the w is a constant, I bought it outside of the integral, and inside of the integral I have sin 3x times cosecant x dx plus sin 3x by 3, again I bought it outside, and this time we have cos 3x times cosecant x dx. So I'm going to call this I1, solve it separately 1, and I'll call this 2, and I'll solve this separately. So integral of 1, this is not I, it's 1, so that will be sin 3x can also be written as 3 sin x minus 4 sin cube x. So 3 sin x minus 4 sin cube x by sin x dx. That is integral 3 minus 4 sin square x dx, 3x minus 4 times integral 1 minus cos 2x by 2 dx. So that equals 3x minus 2x plus 2 cos 2x dx. So that is x plus sin 2x. So it's base integral of cos 2x is sin 2x by 2, so the denominator by 2 and this 2 get cancelled, and we are left with sin 2x, and 3x minus 2x is x, so x plus sin 2x. So that's that, and we have a constant plus c, I guess, and then integral of the second part cos 3x minus times cosecant x dx. So cos 3x is 4 cos cube x minus 3 cos x by sin x dx integral. So 4 cos square x. So what I did is I took out cos x as common, so I have now sin x times cos x dx. Now like what I'm going to do is convert this whole term into sin x terms. So basically we have a derivative of sin x cos x dx on this side. We can assume sin x as u and cos x dx as du and solve it. So that turns out to be cos square x is 1 minus sin square x, obviously. So I'm going to write this as 1 minus 4 sin square x by sin x, since it's going to be 4 minus 4 sin square x minus 3, so that is 4 minus 3 1 minus 4 sin square x by sin x cos x dx. If sin x equals u, then cos x dx equals du, and if we solve it we get ln of u minus 2u square. So that is basically nothing but natural log of sin x minus 2 sin square x. So yp equals minus cos 3x by 3. By the way, we won't have any integration constant. Sorry about what I told earlier. Where is that? Let me just check the previous paper. Okay, it's right here. Okay. So it's yp, we got yp as cos 3x x plus sin 2x plus sin 3x by 3 natural log of sin x minus 2 sin square x. Now so we know that y equals yp plus yh, and yp, as we just now found out is minus cos 3x by 3 x plus sin 2x x plus sin 2x plus sin 3x by 3 3x by 3 natural log of sin x plus minus 2 sin square x minus 2 sin square x, and yh as I earlier wrote that it as a t, but it is actually x. That was a mistake which I have edited in the video. C1 sin C1 cos 3x plus C2 sin 3x. So C1 C2 values we can't find because initial values are not given, any values are not given, so we cannot find out the values of C1 and C2. So y equals minus cos 3x by 3 x plus sin 2x plus sin 3x by 3 natural log of sin x minus 2 sin square x plus c1 cos 3x plus c2 sin 3x. So yeah, that is the final answer. Thank you.